Hello, in tonight's omarvision tutorial, we're going to go over how to train our first ML agent. And so what I have here are a list of steps that we're going to follow. And before I show you those steps and go through them, let's see like what the end result of tonight's tutorial will be. Right here is an example. These little white boxes, they have all been trained with an artificial neural network brain to decide when they have to jump over these obstacles that will come sliding down the black belts. So I'm going to just press play. Okay, so as you can see, they don't all perform the same. They don't even successfully always jump over things. Sometimes they land on it. And that just depends on how well they've been trained, if they make mistakes or not. So let's do this from scratch. So I'll go to Unity Hub. So I'll call it Training 2. Now, while that's opening up, let me just show you, like before the start of this project right here, I had to make sure that MLAgent was downloaded to my computer. It's basically Python source code. And because it's Python source code, I also downloaded Anaconda and created an environment in Python for this MLAgent source code so I could run it on my computer. So that's step one. That is another video that I did right here for MLAgent's install and setup. Okay, the project finally opened. We want to, let's see, what does step 2 say? We want to get the MLAgent from the package manager. So I'll go to Window, Package Manager. I will pick from the Unity registry all packages. And here it is, MLAgents. And let's just install that. So I can close the package manager. First thing we have to do is we actually have to make that scenario. Okay, that'll be our road. Then we're going to have the player. And then we're going to have the obstacle that's going to come down the road. A little obstacle to jump over. Add tag. So let's add one. I'll make all our tags lowercase. We'll just give each of these things their own color. Now that we have the objects and their colors, let's start coding for them. And so I just added a rigid body to the player. And here I created a script, ML player. There's going to be a different class than mono behavior that we're going to want to derive from. In order for me to derive off of agent, I had to use unity.mlagents. Okay, agent basically derives off of mono behavior, so we can still do start, fixed, update, and stuff like that. On the start function, we're going to get the pointer to the rigid body. And then we're going to make sure that the rigid body only moves in the directions that we want it to. So I'm going to check to see if the person is holding down the up arrow key. And if they are, then I'll add thrust. All right, so check what we have here now. We have these components. When I drag and drop the ML player script to add it to the GameObject, it also added a behavior parameters script. Okay, so let's press play and see if our script will actually, make me jump up and down. So it's playing, and when I hold the button, I go up. When I let go, I go down. Now what I want to do is I want to add the script for the log, or the obstacle. So all the obstacle has to do is move on down the road. So the obstacle, basically I just want it to move down. So I have a move speed and it just keeps translating down the road here. So let's see, I'm going to add something else here now because the obstacle is going to come down. I want something to know when it stops. I add this private void on collision enter function. And then I just destroy the, come on, and we'll jump up. Bam, and it disappears. Good. Now the next thing we have to do is make sure when it hits us that it disappears too. And voila, it's basically private void on collision enter. If the GameObject is the obstacle, tagged GameObject, then we'll just destroy it too. All right, press play, and here it comes. It should hit me, and boop, it disappears. So let's make a spawner script to spawn these logs. They're on the road, to have the road spawn the logs. That means also that the logs are going to have to become a prefab. So I drag it down here, and road, let's add spawner script, and then we'll, oops, I just added it twice. Sorry about that. Just need it once. And now let's go edit the spawner script. All right, so here's the code. For the spawner, it's basically I just need to know what the prefab is that I'm going to spawn, the log. And I need a point on this in the scene where I'm going to spawn it at. And then there's an interval of time, a min and a max time, for which I'll do the spawn. So in the start function, I'll invoke the spawn function to spawn. And we don't know how long I'll wait to that. We'll use random range. So here in the spawn, I instantiate a prefab, and then I set its position to the spawn point the user specifies. And what do I do for the next object to spawn? I just invoke spawn after a certain amount of time, whatever that random min-max is. So that's the script. I need a spawn point, give it an icon. All right, the road has the spawn script. We need the prefab, so we'll give it a prefab to spawn. The point of spawning, we will give it the point of spawning. And there's the min-max spawn interval times. And I could jump, or I could hit it, but logs will continue coming. And I hope that is it. Yep, the times are random. See? Okay, cool. So we have our little game scenario. So let me just take a look back here at our steps. It took a while, but we made a simple one-player game with a road, a jumping player, and a moving obstacle. Now we have to make sure that that script that we're deriving off of agent, the ML player script, we have to make sure that that is really, truly ready to do the machine learning. So there's a couple of changes we have to make. We have some overrides that we're going to add, these override functions, and some other things we're going to do. So let's start off with the override functions that we have to add. The first one is initialize. So let's see here. Let's look at the MLPlayer script. And let me just see what we got. Let me shrink it up to definitions. So the initialize function, it's kind of going to replace the start function. Public override void initialize. Okay, and you should have this, see it come up, because since we're deriving off of agent, you can see here it's agent.initialize should come up, and I could pick it. Bam. So because this is C# and the word overrides there, C# will automatically call the base method that we're overriding, but we don't need that. So here in the override, we're going to take what we had in start, and we're going to just put it in initialize. So cut and paste, and I think that should look good. Yeah. Okay, and then that means we don't need the model behavior start anymore. Because, okay, on action received, that means the MLAgent library is going to tell our script to do something, or it's going to send us an action to implement. So on action received, and the way it communicates to us an action to communicate is basically in the form of a vector, an array of floats. Okay, so however many actions our player can do, it's going to have a position in this float array. So what are we going to put in here? Well, I only have one button I could press to jump, so we have one action. If vector action at 0, our first and only action, if it equals 1, then we will call thrust. Okay, fix update here, you're getting ready to be obsoleted. Okay, so let's see what else we have to do. Up here, we're going to have to put a public override void on episode begin. At the start of an episode, what do we do? What do we do? We're going to restart another training scenario test. It's basically, we want to reset the position of the player. And now we need to know what the initial position of the player is. So on episode begin, it sets everything up in the initial spots. What else do we have? I think there's one more function. Initialize, on action received, on episode begin, and then there's this other one called heuristic. So if I'm just translating this whole script to be MLAgent compatible, I'm going to replace the thing that was reading my button press, which was fixed update, with a heuristic function. Okay, so here now I finally have the function that's going to replace this. Public override void heuristic. Okay. And it looks like it takes in a float array of actions. This kind of matches up with the on action received, which is another float array of actions to do. Here's where I set those actions to do. Okay, I don't need that. So let's say that first we're not going to have any actions. So actions at 0 will equal 0, because here it's the 0th position in the array that's going to tell us to do a thrust. So first we'll set it to 0, and then we'll just check to see if the user's pressing the key. Boom. Okay, so heuristic and on action received, they kind of work together. So now I think that everything should work. I kind of eliminated the things that we had from model behavior and used the MLAgent version of them, initialize for start, on action received, and heuristic for the fixed update, reading the input and taking an action. And then on episode begin, which is a specific thing to the training that would happen when we start to get to that point. Let's just run this code and make sure everything works. All right, we should still be able to play the game the same way, pressing the up arrow to jump. Is there an error? Oh, there is. What does it say? Object reference is not set to instance of an object. Oh, dear me. What is it? What is it? Oh, here, original position is not equal to something. Oh, okay, transform original position. And here I'm setting it. Let's just do it the way I did it in the obstacle script. And we'll put a point on the screen and just define it, pass it in. Now we want to position it here with the cube. So let's copy the cube position and then select the reset and paste the position, and boop, there it goes. And we can add a little thing like that, an icon, so you can see where it is. All right, now we have that reset. So now in the MLPlayer, we're going to want to pass in that, and so it shows in the inspector. And I'm just going to keep my public stuff together because I'm like that, just neat. And now let's see it work. I tell you, Unity takes so long to start. And let's jump. I'm not jumping. It's not jumping. So something's wrong. There's one more thing. There's some other things I have to do. All right, so this heuristic, let me just move on episode down because these two are related, so I'll just keep them close together. All right, so when I kind of here, the heuristic thing, I'm kind of setting action to have a value of 0 or 1, the action for jumping is at position 0. I'm just setting it to 0 or 1. Then here on action receive, something's going to have to like actually call out to get that action. It just isn't going to, something's going to have on action received actually fire off. So what we're going to do is we're going to put request a decision. And when a decision is requested, then an action is taken. So the only question we have to think of is how do we make the agent class request a decision? How do we get the MLAgent library to request a decision? Well, we're going to go and do it from over here in Unity, select the ML player, and we're going to add another script here that comes from the MLAgent package. It's called request. It's called decision requester. So I'm going to add that in. And right now it's saying that it's going to request this decision every 5 periods. And we're just going to put it down to 1, so it's just constantly requesting for us right now. And with this, I think the on action receive should be able to fire off. Let's also name this behavior thing. This is where we're going to define the brain once we get it. Let's give this a name, and we'll just call it and we added the decision request. Now I'm going to press play and see if I could actually jump. And I could jump now. So that communication from the heuristic to the actions is happening. Now, to continue setting this up for training, let's use the add reward function. And that's a way to communicate to the MLAgent library of something we like that it's doing or something that we don't like that it's doing. So let's look here at the scene. Something that we're going to like that it does is that it could jump over the log. So how are we going to be able to tell when we jump over the log? Let us take a look at the obstacle, and we're going to add a little wall behind it, something to trigger if we go through it. If we get to that wall, then we pretty much jumped over the log. So I'm going to open up the obstacle prefab, and I'm going to add a wall to it. So that's basically going to be a cube, right? And let's tag that as wall reward instead of wall end. Make sure we tag it. Bam. Okay, so we have this wall reward. Now let's just position it. So this wall, we want it to be a trigger. We want to be able to pass through it. So take the box collider on it and just click the as trigger. So we can actually pass through it, but we could detect the on trigger enter. So now we've made the modifications to our obstacle. So it has that wall. Now in the player, we have to detect when we hit that wall. So, hello player. Let us go to the ML player script again. And let's see, we have on collision enter, which kind of tells us when we hit the obstacle. Ooh, that's going to be bad. We really don't want that. So let's say add reward negative 1.0. It's really bad. Now these values, I'm kind of just picking values that I saw in the examples from the MLAgent projects package. So they were using a -1 for the punishment. And now for the reward, let's do this. Private void on trigger enter. Okay, if other dot compare tag equals wall reward, then we will do an add reward. And usually the adding reward, it's kind of smaller. They had it at 0.1f, so I'll do the same thing. Okay, so the number is positive for things we want it to do. The number is negative for things we don't want it to do. And just look at the steps here for converting again. So I did the reward. Now there's this other thing in the Unity editor side that we have to do, that we should do. And that is, let's look at the properties from the behavior parameters. So in the behavior parameters, there is this vector observation. Let's see what we're going to have to set it to for our example here. Vector observation, we're going to set the space size to 0 and the stacked vectors to 1. So right now space size is 1. I'm going to, oops, oh, that thing's like a little scroll bar. Okay, 0 and 1. And what else do we have? We have vector action, branch size 1, and branch 0 is a size 2. All right, so branches kind of corresponds to things we could do. We can only jump. And over here, there's either 0 or 1, so I'm putting a 2. Okay, we don't have a model yet. That will come when we have the training. The model is actually the brain that will the brain will control the character instead of us, but that comes after the training step. That's why there's this little message over here. Let's check what else we have. The ray perception sensor. Okay, yeah, so we're looking at things, we're seeing them with our eyes, but for this to be an MLAgent, we have to give a way for the MLAgent library to see what we're seeing with our eyes. So they have a script from the MLAgent library package, and that is called ray perception sensor, and we're in 3D, so I'll pick that one. So now what it has these rays shooting out from it. Okay, they're kind of going along this axis like this, and there's these other ones extra around the sides. Now let's think. How many of these rays do we need, and which way do they need to be pointing? We know that the player is going to be going up and down, up and down. So these rays are kind of maybe going in the wrong axis. They're kind of going along the horizontal axis, the horizontal surface here. But for this, it doesn't have a thing to say how to change that and rotate it. So we could rotate the object instead. So let's do that. So here, the transform, let me rotate on the z-axis by 90 degrees. And now we have rays that are going in these directions, okay? So what I was thinking here is we want to make sure when we jump that we don't jump higher than this. So let's add another wall that's above the player, about as high as that is. We never want to go past that top wall. Let's add a punishment if we hit that top wall. So on collision, it's not going to be able to pass through the top wall. So if collision dot, oops, I spelled it wrong. Dot GameObject dot compare tag to wall top equals true. Then we definitely want to punish. So we'll say add reward of a negative amount. Let's just try -1. Okay. There we go. All right. So now when we're jumping it, or we're pressing the button to go up, it can't go up past that, and it's going to have to hit that. That looks good. So we have this whole environment that we can move in only, and the player has these rays that are casting out, and you can see that this ray perception sensor script, it's saying that when I touch this, you see it's red, it knows, and when it's looking forward, it touches that. And this is why having these rays at multiple angles will be good. As a matter of fact, this one should go straight up. Or I can move this back a little. Okay, because I don't want to hit that. So here it is, the rays. Let's see, do we have enough rays? When I go up, all right, we got rays looking in all those directions. We could control the rays over here, the rays per direction. We could add more. We could add less. Of course, the more you add for anything, the more calculation time it's going to take. What are the things that we want the ray to be able to see? What are the things we want it to be able to detect as something that's important? So here in detectable tags, this is a big reason why I gave all my objects tags. I want the MLAgent to know about different things. So how many things do I want it to know about? The road, the obstacle, this, and this. So that's 1, 2, 3, 4 things at least, right? So I'm going to say 4 is the amount of things. So the first one would be the road. Second one is the obstacle tag. The third one is, what's this? The wall. Oh, what's that wall called? The wall reward. So the third one is wall reward. Yep, because that's something we're aiming to be able to hit. And then over here, this one is also something we don't want to go past, and that was wall top. So we got the ray perception sensor, so the MLAgent could see. Let's just check our steps to see what else we have to do. Yep, I added the detectable tags. So now we basically converted our player to totally be ready to communicate with the MLAgent library. The next step is that we actually try to do some training. Okay, so for the training, we're going to have to run Anaconda, and that's a tool that I installed to be able to do stuff with Python. So here's my Anaconda installation. I'm just going to pick the Anaconda Navigator first. It's going to take a while to start up. See this little green transparent logo? But you get to here, the Anaconda Navigator. So what I want to do here, from my setup steps that was in my first video, here we made an environment for the ML agents, and we called it Unity RL. So I'm going to select that. Then from that environment, I'm going to open up a command terminal so I can type some commands. See, and here's the environment Unity RL. So currently, the directory is COMR's users. But I do want the path that these command actions are going to take place. I want them to be my assets folder for my game. So an easy way to get that changed is, let me just show an Explorer so I can get the path over here from Windows Explorer. I'm going to copy that address, and then I'll just go back to here, and I'll use the command cd for change directory, space, and I'll say Control V to paste that path. So now instead of C users omar ck, now it's C omar, now it's my Unity project folder. So the command to type to begin the training, this will start the MLAgent Python code to start up a training. The command is MLAgents -learn. And we're going to see that the MLAgent library, which is written in Python, is kind of going to start up here. And that's a nice thing when you see this Unity picture. That's a good sign. And then finally, down here at the bottom, you see that it's listening on a port. Start training by pressing the play button in Unity. So let's press the play button in Unity to start the training. And soon we should see, yep, that it's trying to run things here. See now the MLAgent library, it is actually controlling this cube. It's going to go pretty slow because we only have one scenario. So what I'm going to do is I'm going to press stop. And when I press stop, over here, the MLAgent library in Python, it kind of stops. And it tells us the results here, and that it made a NN file. It made a neural network file in the results folder. Okay, so it's MLPlayer-6464NN. That's the brain that it made. This brain is going to be very bad because you see it didn't even jump over yet. We didn't train long enough, and we didn't have enough examples to train from. But this is how you know where the file output. So if I go and look back in Unity here, Unity should, yep, here we go. Here's a results folder that it added, and PPO and the ML player, NN. Okay, so this file would be something that we would drag onto the ML player right here for the model. So we're going to make training go faster. So what we're going to do is we're going to like kind of duplicate this little scenario. So let's just make an empty game object, and I'll just call it scenario. Okay, and obstacle, you don't have to be there. You're getting spawned. So scenario, we want the road and we want the player. Let's drag those and make them a child here. Scenario, and now scenario, I'll drag it. Oops, not there. I got to change my location of my assets folder to the top level. I'm going to make the scenario prefab. Okay, now with the scenario, I'm just going to make a bunch of copies, and that way it speeds up the training basically that much faster. So let's do a couple of copies. All right, Control D, and I'll try to make a couple of copies. So what I did was I just made 20 copies. All right, so that's going to help my training go faster. Now let me save this, and I'll go back to the Anaconda window. Now when I type in the command again, MLAgents.learn, it kind of already had done a session. So I could either choose to resume the previous session to continue training it, or I could use the force to force a brand new training from scratch. And it's going to ask me to press play in Unity. Let's see how long it takes for us to see like some results show up in this window here. I just realized I have a problem. If I'm looking here in this window, it says no episode was completed since last summary. I have to tell it when to end the episode. So let me stop the training by pressing this stop button here, and we're going to go to the MLAgent code again, ML player. So some point here somewhere, I have to tell the scenario to kind of like restart itself. You know, let me think. Basically, every time it fails a test, I want it to restart itself. So here, where the reward is a punishment, I'll say end episode. It's time to start over. You failed. Okay. End episode is a method of the agent class that we're deriving off of. And where else do we do a punishment? Over here, end episode. And so we come in here, and this time I'm not going to use the resume command. I am going to use the force command to just start over. MLAgents learn, and just force overwrite and restart. So enter. Let's just see everything start up again. We got the Unity symbol, and then we should get the little message telling us to press play. So press play. And they're off. Let's check the output here. We have our first output. Mean reward of 0.9. Standard deviation of 0.036. Now we're from 0.036 to 0.145. And let's see. Numbers are changing. All right, so these are the kind of numbers we got this time. It looks like they went up and down. Let's see, what's the brain? 352, 500, 352. That's the one we want to try to use. So let's see over here. Let's see what we got there. And open up the prefab to get that brain. This is just player. I can't tell which number that one is. So let's look over here. 4 and 352. And all right, so ML player behaviors. So let's take this brain and put it there, the 352 brain. And let's see if this trained better. So Here we have all the agents, mass copies, and I'll just press play, and I'll cross my fingers. Because, you know, I'm still kind of learning this MLAgent thing. They're jumping and nothing's there. But, they did make it over. Yes, good. Good. It looks like it's doing a little bit better. Anyway, so that's how you train an agent. Voila. You made it to the end of the video. I'm so proud of you. This is my website. The main thing I want to show you is that for any of these videos that you've seen on YouTube, I have the tutorial section, which has the blue links for the projects, and the orange links are the files. Also, you could go over here and play some of the games we made in the game camp.